What I want to do in this video is think about the electron configuration for an atom whose highest energy electron is not in the s block or the p block, but the d block. And to help us think about that with the periodic table, I'm going to rearrange the periodic table a little bit. I'm going to take helium, which it makes sense that it's right over here in the top right because it's a noble gas. It's inert like the other noble gases, has very similar properties. But for the purpose of electron configurations, because helium's highest energy electron is in the s subshell, its electron configuration is essentially 1s2, I'm going to put it over here, and then that allows us to construct essentially an s block. So let me cut and paste that here. So what do I mean? What do I mean by an S block? Well, that means that any of these, there's some exceptions, but the general rule is that if an element is sitting in this block, its highest energy electron is going to be in an S subshell. So this is the S block right over there. Now, for example, potassium's highest energy electron is going to be in the 4s subshell, while hydrogen's highest energy electron, of course, is in the 1s subshell. But it's going to be in an s subshell. Now, that allows us to divide the rest of the periodic table into other blocks. This right over here is the p block. Same idea. General rule is that the highest energy electron in the electron configuration of these elements is going to be in a p subshell. So this is the p block right over there. And as you might have guessed, this in the middle is the d block. This is the d block. And we'll talk about the f block in a future video. This is the f block, and you can actually place it here and kind of push over the d and the p blocks to make space for this. But we'll do that. We'll do that in a future video. So this right over here is the D block. Now, why is this helpful? Well, if something is in the D block, we could say that its highest energy electron, and there's going to be some special cases, but we could say in general, the highest energy electron is going to be sitting in a D subshell. So for example, if we were to focus on iron, its highest energy electron is going to be in a D subshell. Now the D subshell starts to become interesting. For something like, for the S and P subshells, you could say, look at oxygen, and you could say, okay, oxygen's in the P block, its highest energy electron is going to be in a P subshell. And you could even look at its period, and you could say, okay, it's going to be in the 2P subshell. You could actually figure out its configuration. It's going to be 1s2, 2s2, and then 1, 2, 3, 4. So 2p4. Actually, let me just write that down just for fun, just for a review, so we can compare them. So oxygen, we have 1s2. You fill that subshell. Then you go to 2s2. 2s2. You fill that up. You're in the second period. And now you're going to have 1, 2, 3, 4 electrons in the 2p subshell. And how did I know it was 2p? I'm in the second period, 2p. So 2, or the second row, I guess you could say, of the periodic table. So 2p4. So 1s2, 2s2, 1, 2, 3, 4. Now, you might be tempted when you're doing the electron configuration for, say, something like iron. You fill all these up, you get to 4s2, and then you might be tempted to say 4d1, 4d2, 4d3, so on and so forth. But the D subshell, you actually backfill into the third shell. So the thing to remember is when you're thinking about which subshell you're filling, say for iron, and you might say, okay, iron is in the fourth period, but when you're thinking about the D subshell, you're going to take that period minus 1. So its highest energy electron isn't going to be in the it's not going to be in the 4D subshell, but it's going to be in the 3D subshell. But let's make that a little bit more concrete by figuring out its entire electron configuration. So this right over here is iron. So let's see, 1s2, 2s2, 2s2, Then we fill out the p block to get up to electron configuration of neon. So 1, 2, 3, 4, 5, 6 in the p block. So 2p6. And then we come to the third shell. We're going to have 3s2 again. 3s2. And then we're going to fill up the p subshell of the third shell. So this is going to be 3p6 to get to the electron configuration of argon. So 3p6. And then we go to 4s2. We go to 4s2. And now we're going to fill not the 4d subshell, but the 3d subshell. For the d block, you take the period -1. We're in the fourth period. We're going to take one less than that. So this is, so the general rule, you could think of it as 3d1, 3d2, 3d3, 3d4, 3d5, 3d6. So 3, 3d, 3d6. And so that's its electron configuration. We've gotten to the D subshell. Now this is an interesting thing, because when you think about its outermost electrons, the outermost electrons are the ones that are in the fourth shell. They're those right over there. But if you were to think about its highest energy electrons, those are the 3d6, but they go backfill. One way to think about it, we've seen these kind of 3D visualizations of how orbitals look. They're these probability distributions that these electrons fall into depending on their energy state. And one way to think about it is, it starts to, these higher energy electrons are filling in kind of a three-dimensional probability distribution gap in the third shell. So the outermost electrons are in this 4s subshell, but the highest energy ones, one way to think about it, are in the 3d subshell.